If you've used a virtualization software before, something like VirtualBox or VMware, you probably know that setting up a new virtual machine can be tedious. It just involves a lot of manual steps that you have to go through to finally get to the point where you have a running virtual machine. There are some tools out there whose purpose is to make this process faster and take care of most of this tedious, repetitive stuff. Multipass is among the best of these tools, and it can create Ubuntu virtual machines within seconds, and also automate a lot of the tasks that are widely used with virtual machines. Let's get started by heading over to multipass.run. And let's select our operating system. In this video, I'll be using Windows. Notice that Multipass is not a hypervisor. It's an automation tool, but it cannot create virtual machines on its own. It has to rely on something like Hyper-V or VirtualBox for that. That's why it says that we need either a Pro version of Windows or any version with VirtualBox. The difference is that these versions are shipped with Hyper-V, the Windows native hypervisor. The Home Edition of Windows, on the other hand, doesn't support Hyper-V, and that's why if you use Windows Home Edition, you're going to need VirtualBox in addition to Multipass. I'm using Windows Home Edition, so Hyper-V is not available, and I have to go with VirtualBox. Multipass is a command line tool, so we're going to need some kind of terminal to interact with it. You can use the legacy command line tool, or PowerShell, or the Windows terminal, but I'm going to use the terminal that's built into Visual Studio Code. So let's go ahead and create our first virtual machine using Multipass. All we need to do is type in multipass launch. And Multipass claims that it doesn't find Hyper-V, but since I don't want to use Hyper-V but VirtualBox, this message is not that relevant to me, and I just restart the computer and it should take care of it. Okay, the computer was restarted, let's try again. The first time we launch a virtual machine, it's going to take a bit longer, since Multipass has to download the image. But once it's downloaded, the same image can be used to create as many virtual machines as needed. And it's done. We now have an Ubuntu server virtual machine running within our computer. Just think how much work would be required to do the very same thing using only VirtualBox. With the ISO download, configurations, and installation, probably at least 20 minutes. So it's a big difference. We can list our virtual machines using the command multipass list, or ls for short. And we can see that we currently have one instance. Its name, which was auto-generated, is moved author, its state is running, and its image is Ubuntu 20.04 LTS. So, what can we do with this new multipass instance? Everything that we can do with a normal Ubuntu machine. To execute commands on the instance, we can use the multipass exec command. So let's use exec to update our Ubuntu server. We first need to specify the name of the instance, and then just type in the command itself. In this case, it's going to be sudo apt update. And the output from the multipass instance is echoed back so we can see it, and the system is being updated. But in some cases, using the exec command might be somewhat cumbersome, and you might want to just log into your virtual machine and interact with it directly. To do that, we're going to use the multipass shell command. And we logged in. Now, if it looks extremely similar to SSH, this is no coincidence. The shell command is nothing more than a useful shortcut to SSH, allowing us to easily log into our multipass instances. Notice that the instance comes with a default Ubuntu user, and the name of the machine is the name of the instance. And now that we're logged in, we can interact directly with the virtual machine like any other Ubuntu machine. To log out of the virtual machine, we can use either logout or exit. To delete an existing instance, we can use the multipass delete command. And if we list our machines now, we can see that its state is now deleted. To get rid of deleted instances, we can use the multipass purge command. And now we have no instances. Let's create a new instance so we'll have something to work with. One convenient feature of Multipass is being able to easily share files. So let's create a random text file on our Windows host. We can copy this file to our Multipass instance with the multipass transfer command. And the way it works is that we first specify the file that we want to transfer, and then the destination instance. And after a colon, we specify the destination path within the virtual machine. And let's list the contents of the home directory in the virtual machine. And we can see that it was copied to the virtual machine. We can also mount a folder, so it will be shared between the Windows host and the Ubuntu guest. So let's create a folder on the host. And to share it, we'll use the multipass mount command. We first need to specify the path in the host, and then the path within the virtual machine. And we're told that mounts are disabled by default, so let's turn them on first. But turning this option on requires admin privileges, so let's start an elevated terminal. And let's try mounting the folder again. And we can log into the virtual machine. And here we see the shared folder. We can place there anything, either from the host or from the guest, and it will be visible to both. To get the list of the folders we currently share, we can use the multipass info command. And we can see that we currently have one shared folder, and we can see its path on the host and on the virtual machine. Let's talk about networking for a minute. The virtual machine has internet access. But if we take a look at the network it belongs to and compare it to the network the host belongs to, we can see that they are in completely different networks. That's because by default, Multipass uses a NAT network for its virtual machines, which basically means that the virtual machine is behind the virtual router and has its own DHCP server. As a consequence, the virtual machine is in its own network, and the host cannot see it and cannot ping it. But what if we want something more permissive? What if we want to be able to access the virtual machine from the host? For that, we're going to use a bridged network. When using a bridged network, the multipass instance is added to the same network the host is in and gets its IP from the same DHCP server the host got its IP from. First, we need to decide which network we want our instance to be bridged to. To list the possibilities, we can use the multipass networks command. And on this computer, I only have one network adapter and therefore only one option. And its name is Wi-Fi. So let's delete our multipass instance and create a new one that's bridged to the Wi-Fi network. And if we list our multipass instances now, we can see that the new one has an IP address that belongs to the same network the host is in. If we ask the virtual machine itself to display its networks, we can see that the new network didn't replace the NAT network, but was added to it, and we now have both of them. That's because Multipass uses the NAT network to provide some of its services, such as exec, transfer, and the SSH connection with shell. So Multipass gave the virtual machine a second network adapter for the bridge network. Now we can ping the Windows host from the virtual machine and vice versa. Let's see a usage example. Let's say that we want to develop two websites, and for some reason the first website needs to be served by Apache, whereas the second website needs to be served by Nginx. So let's create two new Multipass instances to install the web servers. Now it may be useful to give them meaningful names instead of auto-generated ones. To do that, we can use the -n flag. And let's install the web servers. Let's list our virtual machines. And let's try to access the IP of the Apache virtual machine. And we got the default Apache welcome screen. And if we try to access the IP address of the Nginx virtual machine, we get the Nginx welcome screen. Both Apache and Nginx use the folder var www.html to store the files they serve. So making this folder a shared folder can be very useful. Let's first create the folders on the host. And let's now mount them to the virtual machines. When we used the folder var www.html as a shared folder, its content was wiped out and replaced with the contents of the folder from the host. But since it was an empty folder, we now have an empty website. So let's create a simple HTML file for our website. And let's do the same thing for the Nginx website. And if we look at the websites in the browser again, we can see the HTML we just wrote. This way we can develop our websites right from our host, but we didn't have to contaminate it and install a couple of web servers on it. Let's now say that this setup of two servers, one for Apache, one for Nginx, is something we use a lot. So instead of installing the web servers manually, it could be really convenient if the web servers could be installed automatically as soon as the instance is created. For this, we can use cloud-init. Cloud-init is an automation tool that's mostly used with cloud-based hosting, such as what's offered by Amazon Web Services, but it can also be used with Multipass instances. Cloud-init uses the YAML format, so let's create a new YAML file. And let's configure it to install the Apache package. Let's now create a new Multipass instance and use our YAML file. And let's check its IP. And out of the box, this new instance already has the Apache web server installed. Another example of something that can be done with cloud-init is creating a second Linux user in addition to the default Ubuntu user. We can also use this file for custom commands. We can run any command we want, and it will only be executed when the instance is created. Let's, for example, create a timestamp for the creation of the instance. And let's create a new instance with this file. And let's log into this instance. And we can switch to the other user that we created with cloud-init. And let's see if we can find the timestamp file. And here it is. One more point I would like to talk about is the resources allocated to the Multipass instance. We can see that by default, one CPU is allocated and almost 1 GB of RAM, and about 5 GB of disk space. For basic server usage, this should be enough, but it can be modified. So let's delete this instance and create a new one. To set the disk allocation, we will use the -d flag. For memory, -m, and for CPUs, -c. And if we check what's allocated now, we can see that we now have 2 CPUs and about 2 GB of RAM. So now that we have a more powerful virtual machine, why not equip it with a desktop? Multipass instances are usually interacted with via the terminal, but the desktop is a completely viable option. I'll go with XFCE as it's pretty lightweight, but you can choose any other desktop. It took a while, but it's done. Since Multipass doesn't have native support for graphical user interfaces, we're going to use remote desktop. That's the reason I created this instance with the bridge network. So we'll be able to access the remote desktop server that we're going to install on the virtual machine. So let's go ahead and install XRDP. And let's check the virtual machine's IP. And now we can open remote desktop and enter the IP address of the virtual machine. And here we have it, a Multipass instance with a working desktop. Thanks for watching, and I'll see you in the next one.